Okay, so let's finish up by trying to graph a logarithm. When you're graphing logs, the key thing to remember is, by definition, remember a log is an exponent. So log functions are inverses with exponential functions. And since we know how to graph the exponential functions, we can just flip the coordinates to find the points for the log function. So as an example, let's go ahead and try to graph y equals log base 4 of x. Log base 4 of x. So I don't know how to graph that, but I can rely on this again. Log functions are inverses with exponential functions. So I'm going to graph, first off, I'm going to graph, well, you don't have to graph, but at least find the points. Graph the inverse. Graph the inverse function. Okay, what is the inverse of this? It's just y equals, the base is 4 here, so 4 to the x. 4 to the x. So we'll plot the points just like normal. Let's make a little t-chart here. So -2, -1, 0, 1, and 2. So 4 to the -2, 4 to the -1, 4 to the 0, 4 to the 1, 4 squared. So 4 to the -2, remember anything with a negative exponent, just underneath in the denominator, 1 over 4 squared is 1 over 16. 4 to the -1 is 1 over 4. 4 to the 0, anything to the 0th power is just 1. 4 to the first is 4. 4 squared is 16. Now, this is not what I'm trying to graph here. This is the exponential function. This is the inverse. So you don't have to graph this, but I will just to kind of show you what's going on here. So -2 goes to 1 over 16th. -2 goes to 1 over 16th. So super, super tiny right there. -1 goes to 1/4. So again, only a quarter of the way up. 0 goes to 1. And I made this a big graph. Obviously, you don't have to do this. You could scale it by 2s or 3s or 100 or whatever you want. 1 goes to 4. 1 goes to 4. And 2 goes all the way up to 16. 2 goes all the way up to 16. So let's go ahead and have it shoot up again. It's exponential curve, so it's going to shoot way up in the air. Out this way as well. It's never going to touch the x-axis though, so because we have a horizontal asymptote. Hard to see there. Our horizontal asymptote at y equals 0. Going to get super close, but never going to touch. Okay, but that is not what we were asked to do. We're asked to graph the log function. But because these guys are just inverses, remember, inverse means domain becomes the range, range becomes the domain. So x becomes y, y becomes x. So let's just flip the coordinates. So for y equals log base 4 of x, log base 4 of x, just take these guys and flip them. So 1/16th goes to -2. 1/4 goes to -1. 1 goes to 0. 4 goes to 1, and 16 goes to 2. We just flipped all of our x's and y's. That's because they're inverses. So 1/16th on the x is you start here, you just go barely out to the right here, and you go down to -2. So it's barely over there. 1/4. So again, on the x-axis, you go a quarter of the way over here. That should be a 1, not 2. Quarter of the way over, and then down -1. So get right about there. 1 goes to 0. So right here. 4 goes to 1. 4 goes to 1. And 16 goes to 2. So we're all the way over here. 16 goes to 2. So we're going to come up. We're not going to touch this y-axis at all. Come up, and we're going to shoot out this way. It's going to keep growing forever, but super, super slowly. And this guy, as you might have guessed, instead of having a horizontal asymptote at y equals 0, this guy is going to be right here, just where you can't see it. It's going to have a vertical asymptote at x equals 0. Remember, any vertical line is x equals. So vertical asymptote for the logarithmic graph. This is the one we're after. You don't really even have to look at this one, but it kind of helps to see because remember, inverse functions are simply reflected over this y equals x line here. Right? They're just reflections of each other. We could see that if we label some of our points, right? We have 4, 1 here, and then over here we had 1, 4, Up here we have 216, and over here we have 16, 2. Right? They are just inverses of each other. So 4 squared gives you 16. That's for the exponential function. And over here we're looking at the logarithm, so we're saying 4 to what power gives me 16? That's 2. Over here we have 4 to the first gives me 4. Over here you ask the opposite question. You're saying 4 to what power gives me 4? 4 to the first power gives me 4. So this is a graph of your logs, your exponents.